Okay, in this problem, a lot of you will end up thinking, well, what's going on here? What really is happening? Why are there ions in here? What there are spectator ions that don't really matter for the reaction that's going on, so we don't list it. So zinc as a solid is reacting with an aqueous solution of tin and some other thing. Let's say it's chlorine, just to give us an idea of what's going on. And it's forming ZnCl2 plus tin as a solid now. So what happened was zinc was more reactive than tin. So it kicked tin out of the ionic salt that it was in to form tin 2 chloride, and then tin was out on its own. So that meant that zinc was more reactive than tin. And so I can go through that process and think through it with the rest of them. Copper was not able to push out tin, and so tin, or zinc, oh my goodness, zinc is more reactive than copper. And then we've got tin and copper in the next one. Tin is more reactive than the copper. It's able to kick it out. So we've got, switch up the color here again, tin is more reactive than copper. And then finally, silver is not able to kick out copper, so copper is more reactive than silver by not being able to kick it out. And so we can put this together, do a little bit of deduction here, and we see that in essence, tin can't get kicked out by anything else, so it would be the most reactive of them. And zinc, excuse me, tin is able to kick out copper, and copper can kick out silver, so we could deduce that it could then also kick out silver. And so this should be our reactivity series, with zinc being most reactive and silver being least reactive. And so when we're looking at these, that means that the one that's out front is more reactive than the one that's behind it. And the correct order then would be tin to, or zinc to tin to copper to silver.